Good afternoon. My name is Uma Megeshwari. I am here to tell about the architecture of 8086 microprocessor. In this, the topic we are just going to discuss about is 8086 addressing modes. In this addressing modes, the way of specifying a particular data to be operated by an instruction, that is called as an addressing mode. Here, the types of addressing modes are immediate, register indirect, direct, implicit, and then relative. In this, we will see the type one by one of this addressing modes. In this addressing mode, the immediate addressing mode is an operand data which is being includes within the instruction rather than being stored in memory or a register. Here, in this case, the direct data, that is, the direct immediate addressing mode specifies the operand as a constant value or literal within that instruction. Here in this case, in this image itself, you can see, here there will be no address field and the efficiency will be more, and because it avoids the overhead of fetching the operand from the memory. It will be in a limited range. Limited range means the range of immediate value is limited to by its size of its operand field by the instruction we are just going to see. Next one is the register addressing mode. In this register addressing mode, the instruction mention a particular register which stores some data. Say for example, register is the one which is used to store some information. The same thing also implements here. Here the example for this register is move AX, BX. In this, the move up is the instruction, that is we are just going to send any information from this, that is we are just moving the any information from B to A. So in this register in addressing mode, the operand to be used in an instruction is directly stored one of the CPU's register. So the CPU's register is nothing but, you can have in particular microprocessor we'll be having, like in 8085 we'll be having A, B, C and so on. In PIC microcontroller it will be different, and in another microcontroller 86 or 51 in microcontrollers and all, it will be a different one. So what it is, like what it is used, like the instruction specifies a particular register as a source or a destination of the operand. Say for example, here the BX is the source and AX will be your destination. So the content which has been saving, you are going to save from B to A. Only the thing is, like you are just saving this B to A. This register contains the actual data being used in the operation. Say for example, this is the thing we have seen and how it is being used. Instead of referring a memory, we are just moving directly points to the register which holds the operand. Why it is being used? Why can't we go for any other memory and all? The register addressing is a very faster one because the operand is readily available within the CPU. So it is often used for a frequent data manipulations and operation within the CPU itself. Say for example, we are just want to add something, some R1 register. Say for example, we have two registers R1 and R2. In that the content of R2 is being adding to R1 means you have to give the instruction like add R1, R2. Add the contents of R2 to the register R1 and it is being saving in the particular register R1 itself. Got it? And next register is direct addressing mode. In this the direct addressing mode, the direct addressing, it specifies some address which stores the data. Say for example, move AX, 5000H. Say for example, in this direct addressing mode, the address of the operand is directly included in the instruction itself, meaning the processor does not need to perform any of the calculations of further memory access to operate the operand. This is also known as an absolute addressing mode. This direct addressing mode is also called as an absolute addressing mode. And the explanation for this direct addressing mode is the address in instruction, that is the address of the operand is embedded with the address instruction address field. No immediate access is being done. The processor can directly access the memory location which has been specified by the address in the instruction itself. Got it? And the next one is direct address. Why we are just going for this direct addressing mode? Just directly we are just accessing that one. This mode provides a straightforward and a faster way of accessing the data, because if it eliminates the need for additional memory lookups and also the calculations it has been done in the operands address. So, and the small disadvantage is this, like it have some limited address space only. So, unless or otherwise if we need some particular instruction to be a fixed size, typically we will be going for this direct addressing mode. Next one is register indirect addressing mode. In this register indirect addressing mode, the data is transferred from one register to another by using the address pointed by the register. Say for example, move A, M, that is the memory, that is the M register is been moving to the A. In this register addressing mode, indirect addressing mode, the address of the operand is not directly contained within the instruction itself, but instead it is located to the particular register. So, the instruction specifies a register and the content of the register holds the actual address. Here we will see in detailed manner. Here it is an indirectness and the register content and then memory access. These are all the thing. Example is like moving, imagine instruction move A, like some register. In this case the instruction move wants to move the register A, however instead of specifying the particular memory address directly. So this is the block diagram of the register indirect addressing mode. The next one is relative addressing mode. Why we are going for relative addressing mode? Here the address is being specified by indicating its distance from another address called as a base address. In this register indirect addressing relative addressing mode, the address of an operand is not directly contained within the instruction itself, but instead it can located in the register itself. This instruction specifies a register and the content of the register holds the actual address. Next one is implied addressing mode. Here the operand or implied or not specifically in the instruction. Say for example, rotates the contents of the accumulator to the right by 1 bit or rotate the content of the accumulator to the left by 1 bit. So for this the RRC or RRL is being used here. The relative addressing mode is the address specified by indicating its distance from another address called as a base address. Here this address BP, BX, DI or SI. These are all the relative addressing mode. The classroom activity. Here you can go for this classroom activity, which one was the different from the rest, and find the mistake in this picture. The next one is advantages of 8086. Here it has the flexible data access. Why we are just specifically going for this 8086 addressing mode? It has flexible data access. We can just access the data flexibly, and memory usage is being efficient one, and it supports for data structures, and it has the faster execution. Next one is the assessment. In this case, the zero addressing mode, the operand are stored in dash, whether register, accumulator, push down or stack, which is not a control instruction, and which of the following is not a data transfer operation, and identify the correct addressing mode of the instruction STA2300H. For this type of assessment, your answers are here. You can check whether your answers has been correct or not. Thank you so much. We'll see the next video, next topic in the next video session. Thank you.